Hello, next after our lessons on electricity and chemistry is chemical energetics. Energetics of a reaction will be our first subtopic under chemical energetics. So let's see what this complex topic simply means. Energy can be described as a capacity or the ability to do work. No work can be done without energy. An energetic person will be able to do more work than a person who has low energy. A ball lying peacefully will not be able to do any work. But once you kick the ball will do work by moving a certain distance with a certain force. So once you give something energy, it will be able to do work. Some forms of energy are heat, we have light, we have kinetic, potential, and chemical energy. All these are forms of energy. Remember, the law of conservation of energy says that we cannot create a new form of energy, but we can change from one form to another. The unit of energy is joule with the symbol J. And here is a little conversion where 1 kilojoule is equal to 1000 joule. The K here is just a prefix. Now remember, we have 1 centimeter. The meter is the base unit, and then the centi is also a prefix. In this case, the kilo is standing for 1000. So whenever you see 1 kilojoule, it means 1000 joules. The kilo here is 1000. Okay, so when you have 2 kilojoules, that means we have 2000 joules. So 2 is the number here. The kilo is what? 1000. So we put the 3 zeros, and then our unit comes to the back. So the forms of energy, some of the forms of energy have been shown here. We have two main forms, potential and kinetic, shown here. Under the kinetic, we have sound, thermal, wind, light, electrical. Okay, for the light, we can also talk of the radiated energy. When we go to the potential energy, we have chemical potential, gravitational potential, electrical potential, nuclear, and then elastic potential. Potential energy is just energy stored to be used later. One form of energy which is mostly lost during physical and chemical changes is heat. Now, when a physical change occurs, that means it can be reversed. For example, melting of ice. It can be reversed by freezing the ice again. For chemical changes, example, combustion, let's say burning of wood. The wood burns and then we get ash. The ash cannot be reversed to give us our wood again. So one form of energy that is mostly lost is heat. And there are two main types of reactions depending on how heat is transferred. We have the exothermic and then the endothermic reactions. So the exo and then the endo. These are examples of them. A bonfire will heat up its surroundings when lit. This is because energy is lost to the surroundings. Over here, when this is burning and then you are very close, you're going to feel the heat. This is because the bonfire is losing heat to its surroundings. A melting ice cube cools its surroundings. It is cooling its surroundings because it is taking away the heat in the surroundings. So once the cooling is taking place, the taking away of the heat is taking place, the surroundings become cooler.